When lightning strikes, we see only the final act of a strange drama. Where does lightning come from? Well, from the sky come many searching tendrils. The sky is looking, sending out its questions and yearnings in all directions. The electrical potential is so high that the air breaks down into plasma along thousands of wandering, branching channels. Where will this all lead? No one knows where the lightning will strike. From the Earth also come plasma tendrils. These are fewer, thicker, perhaps just one from each building or hilltop. These responses from dense matter are just as great as the efforts from the sky. The sky and Earth are searching for each other. They are striving to connect. Our eyes, in their usual mode, see none of this. It all happens way too fast and gives off little light that we can see. Eventually, two channels connect. One option strikes, and then all the energy from all the searchings goes racing into that one option. Creating all those electrical potential options takes an enormous amount of energy. But once one potential becomes actual, all the energy from all the other options goes racing into that one actual lightning strike. How does all the energy distributed over so many miles collapse in an instant? This is one of the properties of electrical systems. Where does lightning come from? Let's look up, pull back to the International Space Station, and look at a lightning storm happening on the horizon of the Earth. That blue-white patch on the Earth's horizon is a lightning storm caught in the act of a substantial discharge. You can see the green double layer that surrounds the Earth. Above the storm cloud and below the green double layer boundary, we see red sprites, another electrical discharge. Where do those come from? In the electric universe paradigm, lightning near the ground is one of the last steps of a very elaborate electrical circuit that stretches from the interior of the Earth all the way up to the sun. Academic science has not yet caught up with this and still describes lightning as purely a product of heat and friction in the lowest part of the Earth's atmosphere, disconnected from anything else that is happening in the cosmos. The full circuit, from sun to lithospheric currents, is too complicated to summarize easily. But all of us can understand the circuit's purpose. The purpose of all the electrical machinery surrounding the Earth is to make the sun's electricity digestible to the Earth, and hence to all creatures living on and in the Earth. Without this elaborate electrical machinery, the surface of the Earth would be a barren, blasted, and completely inhospitable place. Let us walk through some of the main transformers in this cosmic current. From sun plasma tubes to Earth's magnetosphere. The sun sends out plasma tubes. The walls of the tubes are made of plasma. The tubes also carry plasma, nourishment from the sun. The tubes also carry information. The width of the tubes is roughly the width of the Earth. Every 8 minutes or so, one of these tubes connects to the Earth's magnetic body and transfers its contents into the outer skin of the Earth's magnetic body. We call this outer skin the magnetosphere. Once inside the magnetic body of the Earth, that solar energy undergoes many transformations. The raw solar energy is hot, on the order of hundreds of thousands of volts. Next, all this goes through the Van Allen belts, which are torus structures of negative or positive charge. 20,000-volt double layers travel through these belts, bringing the matter and energy closer to earthly conditions. At this point in the story, the incoming current takes several paths. We will look at the polar currents. We have all seen movies of the aurora. The aurora are the polar currents made visible. The voltage drop in the aurora is now a few thousand volts. We've gone from, say, 500,000 volt solar wind to 1,000-volt polar currents. Just like the electrical transformer on your street corner, solar voltages are being stepped down to something digestible by the Earth. The polar currents flow both into and out of the Earth. You see some arrows are flowing down into the Earth and some are flowing up and out. You can also see there are other currents, which gives you a flavor of how complex this all is. Watch the electric currents flowing into and out of the North Pole here. When you ask, where does lightning come from, you need to picture all this. I left out many steps. The lightning we see is one of the last steps in a series of complex electrical transformations stretching from the sun down into the rocks beneath our feet. Keep in mind that all this electricity in space was summarily dismissed as impossible after Birkeland first proposed the electrical connection, all the way up to the 1970s, when the satellite data could no longer be ignored. If you ever hear that pompous tone of voice that accompanies statements like, well, we now know that, or, you know, what the electrical universe people get so very wrong is, just remember that whatever YouTube physicist is saying that is standing on a bandwagon that has been going in completely the wrong direction for decades. Let us look more carefully at those polar currents going into and out of the Earth. The Ampere data from the Iridium satellites has been collecting information about these currents since 2009. That's a long data set for anyone wanting to do some analysis. Here is a plot of the net current flow to the Earth over the 5 years 2013 through 2017. Top panel is the amount of current flowing into, red, and out of, blue, the North Pole. The bottom panel is the same for the South Pole. I want you to see how variable this is. It's very dynamic. The amount of current flowing in is never the same as the amount flowing out. And we're talking millions of amps in each direction. We can add up all the current flow in and out for the entire globe. You can see that sometimes there's a net current into the Earth and sometimes a net current flowing out. This is very important as it highlights the complexity of the Earth's electrical circuit. Where is this excess going to and returning from? Mainstream will tell you that these currents do not go into the rocky body of the Earth, but this is largely speculation. It is worthwhile pondering if the supposed dynamo inside the Earth creating the Earth's magnetic field might not, at least in part, be a result of these solar currents entering and leaving the Earth. One difficulty of the data published by Ampere is that the researchers assume the net current flow should be zero, so they do various corrections to try and make this true. But for any set of corrections, the variations persist, and this is not simply a 365-day cycle. It is more complicated. Let us look for a correlation between current flow and the number of earthquakes, this time for the years 2013 through 2023. For the first correlation, if we look at only the current flowing into the North Pole, when the current flow into the North Pole is substantially less than usual, the blue line, then for the next 3 weeks there are noticeably fewer earthquakes than usual. The horizontal dotted line and the gray shaded region show the average daily earthquake numbers and how much variation you would expect just from randomness. A second correlation, looking at the total net current flowing into the South Pole, when the net current is higher than usual, the red line, then the number of daily earthquakes is less than usual for the next 2 weeks. Another correlation, look at times when the total global current flow is very quiet. That is, not a whole lot in or out, because maybe it's the absence of a good robust current flow that causes some earthquake action. The plot shows that after times of quiet current flow, the global earthquake count stays unchanged for a week. That is, the green dots stay inside that gray average band. Then after about a week, the global daily earthquake count jumps up. The statistics here give that jump up a p-value of 0.0005, which means it's super unlikely that it is due to randomness. I'm not claiming to understand why the Earth behaves this way. I am exploring and finding that statistically speaking, the electric current flow through the Earth is definitely correlated to earthquakes. How about lightning? Are the polar currents associated with changes in lightning? The plot looks at times when the total electric current flow through the North Pole is much higher than usual, red, and much lower than usual, blue. And it asks if there are then much more or less lightning strikes on the Earth in the days that follow that. For 2 weeks after lower North Pole current flow, the blue, there are about 10 more lightning strikes each day on Earth than usual. The opposite is true for the 2 weeks after higher North Pole current flow. There are fewer daily lightning strikes than usual. This particular graph deseasonalized both the electric current and the lightning strike data because the current flow and the lightning strikes, they vary slowly together over months and years. I subtracted out those synchronized fluctuations since I cannot distinguish there what is cause and what is effect. So when you subtract that out, it's almost like the solar current and the ground-based lightning are working oppositely. If there's less solar current flow, then the lightning needs to make up for it somehow. The analysis I'm presenting here are sketches. They are indications for future research. And I'm happy to share the Python code and the data sets with anyone that wants to pick up where I'm leaving off. So, where does lightning come from? The EU model, which has been correct since 1908, says that a circuit stretches from the crust of the Earth up through storm clouds, through the ionosphere, through Van Allen belts, through the magnetosphere, through solar flux ropes, all the way back to the sun. The little local story of rising warm air off ground and charged raindrops, all of that is important in the picture of lightning. I'm not saying those factors are irrelevant. I'm saying you need to see the whole. By analogy, when you look at the electric circuit diagram of a simple AM radio and you ask what is the cause of a voltage change in one particular resistor, sure, you could look at the one section adjacent to that resistor, but that's not going to help you to understand anything. The AM radio is a whole. All its pieces behave according to the function of that whole. You need to see the whole.